London Underground is one of the largest and most complex mass transit systems in the world. Each day more than 450 trains carry 2.5 million passengers over its 10 lines. Electricity to power the entire undertaking is generated at London Underground's own power station at Lotts Road, Chelsea. Here, gas-fired boilers supply superheated steam at £900 per square inch to 6 Parsons turbine alternator sets. Each turbine runs at 3,000 revolutions per minute, and with all 6 online, power in excess of 150 megawatts can be generated. At periods of peak demand, further power can be generated at the gas turbine power station at Greenwich. This standby generating station is controlled remotely from the main control panel at Lotts Road. Additional supplies can also be obtained from the national grid. From Lotts Road, alternating current at a pressure of 22,000 volts is fed to the trackside substations. Here, the current is transformed and converted to the 630-volt DC supply, which is fed to the conductor rails. Both positive and negative conductor rails are mounted on ceramic insulators. Each substation is remotely operated from a central control room, which controls current distribution to the entire system. This operation is broken down into a number of panels, each one manned by a control room operator. He is the man who actually switches on and off the supply to any given traction current section. Each control room operator has a direct telephone line to the appropriate line controller, the man responsible for overall control of the traction current on the line in question. At this stage, let's have a look at a diagram illustrating the distribution of traction current. We can see that the power, at 22,000 volts AC, is fed to each substation, where it is transformed and converted to 630 volts DC. Each substation feeds this supply into the positive conductor rail of 2 sections, one in either direction from the substation. As the next substation feeds in the same way, we can see that each section is fed from both ends. This is called double-end feed. It prevents voltage drop within the section and ensures that the section is fed even if one substation fails. There are exceptions to this, of course. Terminus roads, sidings and depot roads are usually fed from one end only. This is called single-end feed. London Underground uses the 4th rail system. The outside conductor rail is positive. The one in the centre of the track carries the negative return, essential to complete the circuit. The outside live or positive conductor rail may be situated on either side of the running rails, but at station platforms it is always furthest from the platform edge. We can see that at each substation there is a gap, called a section gap, between the positive and negative conductor rails of each section. If, for any reason, the traction current is isolated in one section, there is always the danger of a train running into that section from a live section in the rear. To prevent this dangerous possibility, rail gap indicators are placed at substation gaps and are automatically illuminated when traction current has been discharged in the section ahead. Should a driver find a rail gap indicator illuminated, he must stop at it, sound his whistle and use the telephone if provided. He must not proceed until he is instructed to do so. Where rail gap indicators cannot be sighted by drivers at a braking distance, a rail gap repeater is provided. When illuminated, this repeater displays 3 yellow lights on a yellow enamel plate. Now that we have seen how the traction current is generated and distributed to the track, let's consider the various means by which it can be discharged in emergency. At each station in tunnel sections, a headwall tunnel telephone is provided at the departure end of each platform, easily identified by the red plate carrying the words private or tunnel telephone in white. the cover is sealed. If you need to discharge the traction current in emergency, simply break the seal, lift the receiver and depress the plunger for a period of 3 seconds. Tell the line controller who you are and where and why you have discharged the traction current. If you don't get a reply within 3 minutes, replace the receiver and make contact with the line controller via an automatic telephone. Where a driver needs to discharge traction current in a tunnel section between stations, he must first secure his train by means of the automatic air brake and the parking brake. Then pinch the tunnel telephone wires, rubbing them together. He now clips his tunnel telephone handset onto the wires and awaits a reply from the line controller. Again, he waits 3 minutes, telling the controller who he is and where and why he has discharged the traction current. Alternatively, he may contact the line controller by means of a mayday call on the train radio, reporting the circumstances requiring the current discharge. Remember to remove the tunnel telephone handset from the wires, or, if using a headwall tunnel telephone, to replace the receiver, close the box and arrange for it to be resealed. Once current discharge has been obtained, the driver must put down a short-circuiting device at each end of his train. Remember, most sections are double-end fed. In open sections, an emergency discharge of the traction current is obtained by request to the line controller by means of the train radio, signal post telephones, or telephones provided at stations or signal cabins. In all cases, staff must wait for confirmation that the traction current has indeed been isolated. On some tunnel and open sections, for example on the city-widened lines between King's Cross and Aldgate, traction current discharge telephones are provided in special boxes on the tunnel or retaining walls. These are placed at regular intervals and alternate between ground and cab level. In all cases of current discharge, the line controller must be informed of the circumstances within 7 minutes. Otherwise, the supply may be restored without warning. Short-circuiting devices must be put down at each end of the train after the traction current has been discharged. However, where absolutely necessary, they may be used as the means of discharging the current in emergency. Great care must be taken, so let's have a look at how a short-circuiting device is used. The original type has to be unfolded and pinned into the rigid position. Complete this operation as far from the positive conductor rail as possible. Taking care that your hands are not in contact with any metal part of the device, hook the triangular stop over the far side of the positive conductor rail. Pull the device towards you and lower it smartly until it makes contact with the negative rail. Don't forget to look away. An arc drawn by the device could damage your eyesight. The latest type of short-circuiting device is both smaller and lighter than the original type and needs no pre-assembly. Hold the short-circuiting device in one hand by the central grip. Lower the leading end onto the positive rail, then facing this rail, lower the rear end smartly onto the negative rail without hesitation. Remember, short-circuiting devices are only found on trains. Finally, where a section is single-end fed, usually a terminus road siding or depot road, the traction current may be isolated by means of current rail isolation switches located in the distinctive yellow cabinets. These cabinets are always in pairs, one for the positive rail with red identification plate and one for the negative rail with blue plate. Both positive and negative switches must be opened to effect an isolation. Using a wooden-handled switch pole, each switch is unlocked top and bottom. Then, looking away from the switch, the knife blade is pulled smartly out and down. Once both positive and negative switches have been pulled, Don't forget to place a red flag or red hand lamp facing the oncoming traffic to prevent a train inadvertently overrunning the isolation point and energising the dead section. Only a qualified member of London Underground staff may operate these isolation switches, and only on the instructions of the line controller. No person should go on or near the track unless authorised to do so, nor should any person be on or near the track unless he or she is wearing high visibility clothing. Conductor rails must be considered live at all times, unless a specific assurance has been obtained that the traction current has been discharged. The conductor rails or overhead line equipment of adjacent BR tracks must also be considered live at all times. If for any reason the headwall tunnel telephone or tunnel telephone wires are defective, a T-board will be exhibited adjacent to the telephone cabinet. In the absence of a T-board, a member of staff will be posted to warn drivers that the headwall tunnel telephone is inoperative. If you are a member of the emergency services, do not approach live rails under any circumstances until you have received an assurance from a member of London Underground staff that the current has been discharged and that it is safe to do so. Physical contact with a live conductor rail will result in death or serious injury.